Hey y'all. Today we're going to be looking at a really important skill in chemistry laboratory, and that is going to be how to pick an indicator. So we're going to get started by looking at what are indicators and then determine the best indicators to use in any circumstance that we might be put in. Let's get started. Let's get started with a quick definition of an indicator. Now, indicators are substances that change color. And in this unit, we're focused mostly on acid-base indicators. However, there are indicators that aren't for acid-base reactions. There are indicators for things like redox reactions, for example. But our focus this unit is on acid-base indicators. An acid-base indicator is often itself a weak acid or base. And as such, the acid-base indicator has its own Ka or Kb value. That's an important thing to understand because we're going to use that Ka value of the indicator to determine where the indicator is going to change color. We're fortunate in chemistry to have a number of acid-base indicators that change color at different pHs. So if you look at this graph, you can see that we can pick an indicator to change at almost any pH that we might be targeting for our endpoint of titration. One thing to understand here is that where these indicators change color, the pH is equal to the pKa of that indicator. And remember, pKa is the negative log of the Ka value. So what that tells us is that we can pick an indicator without seeing a graph like this. We could pick an indicator just by knowing its Ka value. If we know the Ka value, then we know the pKa value. If we know the pKa value, we know the pH at which that indicator is going to change color. If we know the target endpoint, we then will pick the indicator with the same pKa as the pH of that endpoint. All right, question for you. If I wanted to end a titration at a pH of 11, which of these indicators would I choose? Think about it. Did you pick alizarin yellow? If you did, you're right. And the reason is because the pKa of that indicator is somewhere between a 10 and a 12. That means its color changes between the 10 and the 12. And we know that if that's where I want to end the titration, that would be the best indicator to use because the pH of color change, the pKa, matches the point at which I want to end the titration. Let's take a look at an example. Here I've got two titration curves, and I have a series of indicators, and I want to pick the best one to use in each situation. So if you notice the left graph here is a weak acid titration where I'm adding a strong base, and the curve on the right is a strong acid titration where I'm adding a strong base. Now I can tell this by looking at the shape of the graph, but I can also tell this by looking at the equivalence point, or I can tell this by looking at the title of the graph. Okay. Now, if you notice that we want to end at the equivalence point, we would determine which indicator based off of the pH of that equivalence point. The equivalence point of the graph on the left is right around 8.5. And as a result, we want to pick an indicator that is going to change color right around that same place. Generally speaking, we're picking an indicator that changes within +1 or -1 of our target. In this case, thymol blue is going to have a pKa value right around 9. That means it's going to change color somewhere between 8 and 10, which is right in our wheelhouse for the indicator that we want to pick for this titration. So if I was looking to end at the equivalence point of the left titration, I would pick thymol blue. Now the curve on the right is kind of tricky because it doesn't appear immediately as though either of the indicators really does a good job of changing color right around our equivalence point. See how the thymol blue is above and the methyl red is below? But here's the thing. Notice where that equivalence point is, and notice how different the concentration of NaOH is between where the equivalence point is and where those indicators change color. It's a vertical line. Because it's a vertical line, I can use either indicator in this situation and get the exact same result, because adding one more drop of sodium hydroxide to this titration isn't going to make a substantial difference. And that's probably going to be the difference between the color change of the methyl red and the color change of the thymol blue. So for this strong acid, strong base titration, because of the fact that we're not adding any more sodium hydroxide between when the methyl red or the thymol blue would change color, I could use either one, even though the indicator changes color at a pH that's substantially higher, or in the case of methyl red, substantially lower than our equivalence point. All right, how about this one? If I want to end the titration at a neutral pH, 7, which of these would be the best indicator to use to do that? What do you think? Did you say bromophenol blue? If you did, you're right. And the reason is because the color change of that indicator is between 6 and 7. And remember, we want an indicator that changes color within 1 pH unit of where we want to end the titration. All right, in this case, that bromophenol blue would do that just perfectly. All right, so that wraps up today's video. Today, we took a quick look at acid-base indicators. We determined what they were and also how to pick the best indicator in any acid-base titration. Remember, when we're looking at indicators, the pKa of the indicator should be plus or minus 1 of the pH at the endpoint of our titration. Today's video was written, directed, and produced by Mia Halpin. Thank you all for watching. I hope you enjoyed it, and I'll see you in the next one.